Hi everyone, this video is going to be a review on how to solve absolute value equations and how to solve absolute value inequalities. We're going to start with the equations. This is section 1.8 of our textbook, and we're going to start with the equations. And the first one I have written here is the absolute value of 2x minus 5 is equal to 3. Now to remember that an absolute value, you're looking at like the inside piece. To have an absolute value of 3 means that we are 3 units from 0. So this mess is either this side of 0, 3 units, or this side of 0, 3 units. So to solve these, we actually have to solve two equations, because 2x minus 5 could be a positive 3, or 2x minus 5 could be a negative 3. So we have to solve those two equations. Now on this one, we're going to add 3 to both, or add 5 to both sides. So 2x is going to be equal to 8, and dividing by 2, we get that x is equal to 4. Same steps over here. So adding 5 to both sides leads to 2x is equal to positive 2, or now dividing by 2, x is equal to 1. And if we substitute those back in, 2x times, or 2 times 4 is 8, minus 5 is 3, and the absolute value of 3 is 3. Substituting in the 1, we get 2 minus 5, which is negative 3, and the absolute value of negative 3 is also 3. So we do have two answers that will work. Sometimes they're a little bit more complicated, and the thing to do here is to isolate that absolute value part first. So I'm going to first subtract 5 from both sides. So subtracting 5, we get that 3 times the absolute value of x minus 7 is equal to 9. And now what I will do is I will divide both sides by 3 so that I have x minus 7 in absolute value is equal to 3. And like we did in the problem above it, we're going to have to create two equations, because either that x minus 7 is equal to 3 or x minus 7 is equal to negative 3. Adding 7, x is equal to 10. Adding 7, x is equal to 4. So again, we get two different solutions. They get a little bit more complicated when we have inequalities, and we have to remind ourselves of where these inequalities are, or how we solve them. So if I have something like the absolute value of something is less than c, where c is going to be a value, c is a number. And actually c is going to be a positive number for the most part. If it's negative, we'll talk about that later. But if c, absolute value of c, x is less than c, that means we're going to be c units from 0. So looking on a number line, if here is 0, and I'm going to put c and negative c on both sides. If I want it to be less than, that means I've got to be closer to 0 than that. So that means I'm going to be in between those two values. If I'm equal to, that means I can simply include those values. So c and negative c will have solid dots, because we'll be able to include them, but we still want to be smaller, so closer to 0. To solve them, we will be solving the equation where this x, or this stuff, is between a negative c and a positive c. In this case, we will have that inclusion piece. Looking at the greater than, again, we're going to be c units from 0. So here's c and negative c. If I want to be further away, greater than, that means further away. So I'm either out here or down here. So we can't do these together, so we're going to have to do two equations. So either x is smaller than negative c, or x is greater than that positive portion. If we have the equality, we're simply going to add those c's into our solution. So we'll have the equality piece as well. So x is less than or equal to negative c, or x is greater than or equal to c. All right, let's do a couple examples here. So here we have the absolute value of x minus 5 being less than 2, which tells me that I can write it, that's this first one, that we can go between negative 2 less than x minus 5 less than 2. One thing to note is if you write this as your compound inequality, the outside pieces should make sense. So negative 2 less than 2, that is a true statement. Now to solve this one, we want to add 5 to all three pieces. So adding 5 would give me 3 less than x less than 7. So I can write this on as a set builder notation, we can write it on a number line, or we can write it in interval notation, which is the most common method as we progress further into mathematics. So in its interval notation, we're going from 3 to 7, not including either of those endpoints. So hence the round brackets. All right, let's do another one. 3x plus 2 greater than or equal to 4. Okay, so this is one that we're going to be on the outside edges, so outside, further away than 4 units, which means that 3x plus 2 is got to be greater than or equal to 4, or 3x plus 2 is going to be less than or equal to negative 4. Okay, if you tried to write this as a compound inequality, so kind of put that and then put the negative on the other side, I'm going to do this, but I'm going to do this because it'll help see that it is not correct. Okay, I want you to look at the outside edges. So this is telling me that 4 is less than or equal to negative 4, which is not a true statement, which is why we can't write it as a compound. We need to split it into the two ends, because you can't be bigger than 4 and less than negative 4 at the same time, because you're either on the upper end or down on the lower end. And now I'm going to solve these two separately. So solving this one, we're going to subtract 2, so 3x greater than or equal to 2, and then dividing by 3, 3x is greater than or equal to 2/3. Here we will subtract 2, 3x less than or equal to negative 6, dividing by 2, or by 3, sorry, x is less than or equal to negative 2. Since we are on an upper end or a lower end, I'm going to write these as inequalities. I'm going to write the one with the negative first, because thinking on the number line, here's my negative 2, here's my 2/3. We are here and smaller, here and bigger. So this one I would write as negative infinity to negative 2, including the negative 2. We never include the infinities. And then we would go from 2/3 up to infinity, and then adding those two together, we put a little union symbol, and we go from there. Okay. Similar problem, just a little uglier looking. Again, we have that greater than or equal to 4. It's going to start out the same way, so it doesn't matter how messy this thing is in the beginning. It is that ugly mess, greater than or equal to 4, that ugly mess, less than or equal to negative 4. Again, with the greater than, we have to split it into the two pieces. And now to undo this ugly mess, we've got this divided by 2. So I'm going to multiply both sides by 2. Since 2 is positive, it does not change the inequality symbol. So x plus 1 greater than or equal to 8. Subtracting 1, x is greater than or equal to 7. On this side, this equation, multiplying both sides by 2, x plus 1 less than or equal to negative 8. Subtracting 1, x is less than or equal to negative 9. Again, I'll put them on a number line to help me. Here's my negative 9, here's my 7. Solid dots because of the equal sign. We're going below 9 or above 7. This would be written negative infinity to negative 9, including the 9, because we included the negative 9 here. 7, including the 7, up to infinity, and union. And we do like to write them from smallest to largest, like the number line goes left to right, smallest to largest. So get into the habit of writing this mathematically correctly. We like to think, smallest to largest. All right, I have one more example, which is a little bit harder, and I did put a star by it because it is a little bit harder. And we have this x piece, or that absolute value piece, in the bottom. So what I want to do is I want to take reciprocals of both sides. So I'm going to try to see what happens if I take reciprocals of both sides. So let's say I have 2 is less than 3. So what happens if I take reciprocals? 1/2 and 1/3. Now which one is smaller? Which one is bigger? Okay, actually 1/2 is larger than the 1/3. So when I take a reciprocal, it changes that inequality. If you wanted to think of maybe 1/2 and 1/3 are too close to each other, maybe try a different piece. 2 and 10. 2 is a lot smaller than 10. And this would be 1/10. 1/10 is a lot smaller than 1/2. So I'm going to take reciprocals of both sides. Taking the reciprocal here gives me x plus 7 in absolute value. Switching the inequality is now less than 1/2. This is now a less than symbol, so I'm going to be shorter or closer to 0 than 1/2, which means I can write this as a compound inequality. So negative 1/2 is less than x plus 7 is less than 1/2. Looking at the outside pieces, that does make sense. And now to solve this, I'm going to subtract 7 from all 3 parts. So subtracting 7, so negative 7 and negative 1/2, 7 is like 14 halves, so negative 15 halves is less than x is less than, this is a negative 14, so negative 13 halves. Writing this in terms of an interval notation, I could put it on the number line. Here's my negative 15 halves. Here's my negative 13 halves. Going between the two, open circles on both. So interval notation, negative 15 halves, round bracket because we are not including it, up to a negative 13 halves, round brackets. If you had preferred decimals, a negative 7.5 up to negative 6.5, that would have been acceptable as well. I prefer fractions because a lot of times our fractions are not nice decimals. Sometimes they are, sometimes they are not. Hopefully this reminded you of how to work with absolute value and equality or inequality statements. There are more practice problems in the textbook as well as out there on our WebAssign account. Good luck.